Good day, students. Once again, I'll be recording this video on the topic of compound interest. And I'm under the assumption that you already went through the recording on simple interest. Although to some extent I will do comparison, or in one of the questions or the exercise here, do a comparison of simple interest and compound interest. But this is introduction on compound interest, and I will go in details doing examples or activities on this topic. Now it says compound interest. In the case of simple interest, we have learned that the interest is calculated only once over the period of the investment. That means you only earn interest on the amount that you have invested, and you earn that over the period of the investment. However, in the case of simple interest, we will learn that the interest per time or per compounding period is added to the principal, with the results that the principal amount will increase periodically. That means when it comes to compound interest, we earn interest from the amount we have invested, and we earn interest on the interest that we have earned. In other terms, we accumulate interest to the amount that we initially invested, which is normally called the principal or the present value. So we earn interest or on interest, in other terms. It's clearly stated that the principal amount or the amount invested increase periodically. That means every time the interest is earned or compounded, that will be added back to the amount that we have invested. And the interest for the following period is greater than the interest of the previous period, because the interest for the first period will be based on the amount we have invested. Then that interest will be added to the amount that we have invested, meaning now the interest for the following period will be based on the amount we have invested plus the interest of the first period. And I will explain all of that as I proceed with the activities. In practice, however, the interest is compounded more often than once a year. That means we can earn interest every month if we want to do so, or we can earn interest every 6 months, we can earn interest every 3 months. That will be what we call the compounding period. That means it may be compounded annually. That means we can earn interest once a year and we add it back to the capital or the amount that we initially invested. Or we can earn interest biannually, meaning every 6 months we can earn interest, and that interest which we earn every 6 months will be added back to the principal amount or the capital that we initially invested. In the case where the interest is compounded biannually, or half yearly, or twice a year, it can be any of the scenarios, but it means the same thing. And we can earn interest for monthly. That means every 4 months we can earn interest, and we add that interest back to the amount that we have invested. Or it can be quarterly, which is every 3 months. Remember, a quarter is made of 3 months. Or we can earn interest every 4 months, or every 2 months, or every month we can earn interest. Remember, every time we earning interest, we call it the compounding period. That means we compound or we accumulate the interest back to the capital or the balance that we have beginning of the period or beginning of the compounding period. Now, with M indicating the frequency of yearly compounds, that means if we are saying that the interest is earned or is compounded annually, that is indicated as M. M indicating the frequency, meaning how often are we compounding the interest, or how often are we adding the interest back to the principal or the capital that we initially invested. Now that when we deal with the formulas, it will be indicated as M, and you will see that as we go further. That therefore means that if the interest is compounded annually, that means interest is compounded once a year, which I've highlighted that to be once a year. And when it's once a year, that means our M is once is 1, meaning our frequency over the period of a year is only 1. That means we only earn interest once a year, and we add it back to the capital that we have invested. Now, when the interest is compounded biannually, meaning every 6 months or twice a year, that means our M will be 2. That, remember, M indicates the frequency of times in which the interest will be accumulated to the amount that we initially invested. So now M will be 2 in the case where the interest is compounded biannually or 6 monthly or twice a year. But in the case where the interest is compounded every 4 months, remember we have 12 months in a year, so 4 months will be 4 plus 4 plus 4 in order for us to get to 12, which is 1, 2, 3. That means when the interest is earned or compounded every 4 months, meaning we'll earn interest in the 4th month and we add the interest back to the capital that we have invested. That means interest in this case will be compounded 3 times a year. Therefore, our M, being the frequency of the yearly compounding, will be 3. And now second last will be when the interest is compounded every 2 months. Then I will say, how many 2 months do we have in 12 months? It will be 12 divided by 2. That means the interest will be compounded 6 times a year. Therefore, now that will be indicated as M being 6. That means we will earn interest 6 times a year whenever the interest is compounded every 2 months, because there are 6 2 months in 12 months in a year. Then the last compounding period, it is when the interest is compounded monthly. That means each and every month we earn interest, and that interest will be added back to the capital that we have invested each and every month. So now that will mean the interest is compounded monthly, meaning our M will be a yearly compound of 12 times. Now, thank you for that, and still proceeding. Then we will continue now. This is just the introduction in terms of the theory. And I will come back when it comes to this and refer you to this analysis of M, more especially the frequency of the compounding period in a year, which is M. I'll come back and explain all of this. What does it mean and how do we apply it? Now we have our first example. And our first example says we are to compute the interest that is earned if 180 is invested for 3 years at 6.5% per annum compounded annually. Now we know that we have invested this amount, and this amount that we have invested is denoted as the present value, and I want to highlight the present value now because I'll be dealing with that as the time goes by. And we know that 3 is the number of years, which is our N being the period that this investment has been invested. So in this case, we have 3 being the period of the investment. Then this amount is invested for a period of is invested at 6.5% per annum, compounded annually. That means it is compounded once a year, which indicate that it is only once a year that we earn interest. That means if we have invested this amount for 3 years, we are going to earn interest 3 times, in other words, because we only accumulate interest once at the end of the year, and once at the end of the year, and once at the end of the 3rd year. So now that means interest will be compounded 3 times over the period of 3 years. Why? Because our interest is compounded annually, and annually means once a year. Now I will not use the calculator, and I don't want to focus on the present value. I just want to use the manual calculations in terms of how to calculate the interest that was earned over the period of the investment, and at the same time how to calculate the future value. Remember, for us to be able to calculate the interest that was earned over the period of 3 years, we need to know how much was invested. We need to know the amount that was invested, and the amount that was invested plus the interest for each of the period will give us what we call sum accumulated, or what we call the future value. and we'll still talk about that in details as we proceed. Now let me do the workings on how we calculate the compound interest. Now we have the original amount that was invested. We need to first start with the original or the principal amount that was invested. In this case, we have a principal amount that was invested, and this principal amount is an amount of 180 rands. Now we earn interest annually. That means we compound interest every end of the year. So now we'll need to calculate the interest for year 1. Then we calculate interest and year 1. How much is the interest end of year 1? The interest at the end of year 1 will be the amount that was invested, which is 180 rands. Multiply this by 0.065% times by 1. The reason why we multiply by 1 is because we are looking for the interest only for one period or one compounding period. One compounding period in this case being a year, which is the interest only in year 1. So now that means in this case we'll say 180 multiplied by 0.065, then we multiply this by 1, and this will give us the interest for year 1. Remember, this interest is earned from the amount that we initially invested, the interest for the first compounding period. So now that means our interest for year 1 will be 11 rand 70 cents. So now we need to add this interest back to the capital or the present value or the initial amount or the principal amount that we had in the beginning. Then after we say plus 180, this will give us the balance at the end of year 1 as 191 rand 70 cents. So this will be opening balance beginning of year 2. However you write it, it doesn't matter. It could be closing balance of year 1 or opening balance in year 2. So let me just say opening balance year 2. So now this will be our opening balance in year 2. Then after now we need to calculate interest for year 2 again. We're calculating now interest for year 2. And interest for year 2 will be calculated from the balance we had at the beginning of year 2, not from the capital that we initially invested. Remember, when it comes to simple interest, interest is only earned on the amount that we have invested only. But when it comes to compound interest, we earn interest on the balance at the beginning of the period, of which the beginning of year 2 balance was 191.70. So now the interest will be earned on this 191.70, meaning now interest for year 2 will be greater than the interest of the previous period. If you remember on the theory, there was a sentence that said that the interest for the following period is greater than the interest of the previous period. Why that is the case? It is because the principal amount increases periodically, and we can see that our principal amount has increased by the interest of year 1, which is 11.70, and it became 191.70. Now, meaning the interest of year 2 will be calculated on the increased principal amount, which currently is 191.70. So now let me calculate the interest in year 2, meaning interest at the end of year 2. Interest end of year 2. And the interest at the end of year 2 will be calculated on the opening balance of 191 rand 70 cents. We multiply this by 0.065 times by 1. Remember, the reason why I multiply by 1 is because I am only calculating interest for one period, which is only year 2, because I've already calculated interest for year 1. Then now we will say 191.70 times by 0.065 times by 1. This will give us 12 rand 46 cents. 12 rand 46 cents plus 191.70 will give us the balance at the beginning of year 3 or balance at the end of year 2. And the balance will be 204 and 16 cents. So now this will be the balance at the beginning of year 2, or the balance at the end of year 2, or balance at the beginning of year 3. Now this will be an opening balance. Opening balance, I prefer to use the term opening balance because it's very familiar also in financial accounting. Now we have our opening balance year 3. Then we need now to calculate interest once again, which is our interest end of year 3. And year 3, we need to calculate our interest. Then our interest end of year 3 will be 204.16 times by 0.065 times by 1. It will give us interest of 13 rand 0.27 cents. Then we add that back to the capital that we had, or the capital that has increased in the past 2 years, 0.16. And this gives us 217 rand 43 cents. Then this is what we call the final amount. And we know that the final amount can be called future value. This is the final amount, and which I want to say final amount is the future value, which is the value of the investment at the end of the investment period, or at the end of 3 years, which is the scenario we're talking about. Now we know that we initially invested 180 rand, and we earned interest of 1170 and interest of 12 rand 46, and we have earned interest of 13 rand 27 cents, and we can see that the interest has been increasing, or has been greater than the interest of the previous period, because our principal amount has been periodically increasing. Now we initially invested 180 rand, and the future value of this amount after 3 years became 217 rand 43 cents. That means the difference between the initial investment and the future value will be the interest that is earned over the period of the investment. So now when we want to calculate our interest, which is our I, it will be the difference between the two, where we say 217.43 minus 180, and this will give us 37 rand 43 cents. So now this will be the interest that is earned over the period of the investment. Now this is exactly what we are required to calculate or to compute the interest earned if 180 is invested for 3 years at 6.5% per annum compounded annually. Now it's not always the case that you will be required to calculate only interest at the end of the investment period. You can be required to calculate interest only for year 3, or you can be required to calculate interest only for year 2, or you can be required to calculate interest only for year 1. But in this case, we just calculated the total interest for the 3 years in which this investment was invested for. So yeah, this is how you will be dealing with this. And remember, I'm using manual calculations. And if, let us say, this amount was invested for a period of 30 years, if this was 30 years, that will mean we'll have to calculate for almost 2 pages, doing all this working going down. So now that is why it is important for us to use the functions of the calculator, where the calculator can do shortcuts for us, or we can use other formulas that can simplify this calculation. So now the next part, now I will be introducing you to the other way of calculating from the present value to the future value. Then after, you just strike the difference between the two in order for you to get to the interest that was earned for the period of the investment. Now the next part says the principal amount, which is the future value, at the end of the time period is made up of the original principal amount, which is the present value, plus the increasing amounts of interest. And you can see that honestly, the future value, which is the amount or final amount at the end of the period, is made of the principal amount, which is the 180, plus the increasing interest amounts, which was 11 rand 70, plus 12 rand 46 and 13 rand 27 cents. And this is really clear based on what we have previously calculated. Now, it says we can use the formula in this scenario, and the formula says S, which is sum accumulated, equals A, and we know that A is the present value, into 1 plus I, and we know that our I is the interest 0.065, divide by M. Remember, we know that M is the frequency of the compounding period in a year, meaning how many times is the interest compounded over the period of a year. And in this scenario, we're told that interest is compounded only once a year. That means annually. That means our M will be 1 because we only earn interest at the end of the year. It's not every 2 months, it's not every 6 months, it's not every 4 months, it's either not every 3 months or every quarter. Then we say is to M, of which we know that our M is 1 times by N. Our N, remember, it is the period of the investment, and in this case the investment was invested for a period of 3 years. So now we can easily calculate the sum accumulated, which is the future value of 217.43 with the use of this calculator. Now this formula means that, or we can split the formula in details, where S abbreviation means the compound amount at the end of the time period, which we indicate that as the future value when you use the functions of the calculator. And A being the principal amount or the original amount invested, and we know that is the present value. And I indicating the interest rate per period, which we know that the interest rate is 6.5%, which can be in decimal 0.065. And N is in years, or N is the time in years, and we know that our N is equal to 3 years. And I want to highlight that when you do the formula, please make sure that your I is recorded in decimals, not as a full number. It must be in decimal 0.065 whenever you work your answer using the above formula. Which is very important, more especially when you don't have a financial calculator as per yet. It's very important to master this formula. Even if you don't have a financial, even if you do a financial calculator, it still becomes very important because it might be useful for shortcuts calculations. Then we know that M is frequency of yearly compounds, and in the scenario which we have, the interest is compounded only once a year, meaning our M will be 1, as I highlighted before. Now let us do this exercise or example 3.1 using the formula that we have above. Now we know that they say sum accumulated is equal to present value, and our present value is 180. Remember the same scenario which says compute the interest earned if 180 is invested for 3 years at 6.5% per annum compounded annually. So now we are calculating the same future value, and then after we say present value minus future value will give us the interest that was earned over the period of 3 years of this investment of 180 rands. So now we say sum accumulated is equal to present value, which is A, into 1 plus 0.065 divided by M. Remember, M is the frequency, meaning how many times is the interest compounded in a year. In this case, our interest is compounded once a year, meaning annually, and there's only 1 year in 1 year. Is to M, our M is 1 times by N, and our N is 3. That means 1 times 3 will give us 3. So if you want, you can just write 3. That will not be a problem. It is very important to write these brackets in your calculator, because your calculator will or can sometimes give you the wrong calculation when you don't put these brackets. So now this one is very easy and very simple. And if you are using the Sharp calculator, I just want to teach you something that you might not be aware of in terms of how to use the power or the fraction, or to the power something. So now in this case, we will say 180, open brackets, 1 plus 0.065 divide by 1, and we close brackets. Then now when you want to write this power, it will be second function dip, if you see the function that is under C below the PV function, where it says PV, there's a button that says dip, then you say second function dip, then it will give you something that is like a power on top. Then after you open your brackets, you say 1 times 3, which is 3, then that will give you equal. Then your answer will be straight 217 Rand 43 cents. So now this formula will give you the sum accumulated or the future value. And the future value which we previously calculated in our past calculation as 217 Rand 43 cents. So now with that being calculated, it means we can easily calculate the interest that was earned on the investment. And the interest that was earned on the investment will be 217 Rand 43 cents minus 180. Then if you do that minus 180, it will give you an amount of 37 Rand 43 cents. And you can see that either we use the formula or we calculate for each interest earned in each and every period, we still get to the same interest that was earned over the period of the investment. And you can see that this is a very, very, very long method that we wouldn't recommend students to use during exams or during any assessment, because it will take time, because most of the times you might be given investment that is invested for a period of 5 years, 10 years, 15 years, or 20 years. So having to calculate interest for each and every month and to do these workings will definitely consume a whole lot of your time. Now with that being said, I just want to hold this activity here, then after the next recording will be in 3.2, 3.3, 3.4, 3.5, and up to 3.6. Then now I will be introducing you to the functions of the calculator, how we can get to the same future value of 217.47 without using the calculator and without using the manual calculation that we dealt with above. Now, how do we do all this with the easy formulas or easy functions from the use of our educated calculator? With that, guys, let me say thank you very much. See you in the next recording. Bye.